Hello, in this video we are going to make an introduction for t-test analysis with starting with one sample t-tests, and again we are going to use one of the sample data files from IBM SPSS 3 car with the underscore among sample files. Let me start with make a reminder about what t-test is and one sample t-test means. The t-tests are type of inferential statistics mainly used to determine whether there's a significant difference between the means of two groups. And in this video we are going to talk about one sample t-tests. One sample t-test compares the mean of your sample data to a known value. In other words, you have a group of data and a predefined known value. You want to compare the mean of your sample data with this predefined known value. Considering what kind of situations this can happen, we can give some examples. For example, you may not be able to access the previous data sets and only know the mean value. For example, you might know the university entrance exam mean score or school average, and you want to compare your class scores with this average. Or you may know the parameters of the population and want to compare your sample with this population parameter. Of course, you can add new examples according to your research design. Okay, to do one sample t-test analysis, we should again when we look at our data sets, 3 car with an underscore data set. We have scale, nominal, and ordinal type of variables, price of primary vehicles in a country based on $1,000, age in years, gender, income category, but we will just focus on price of primary vehicles in this video. So one sample t-test, to do one sample t-test analysis, first we should go to the analysis tab from the top windows and compare means, and you will see one sample t-tests. One sample t-test is referred to as a parametric tests, parametric analysis, and needs to meet certain assumptions before conducting this analysis. Your data should meet these requirements for the testing to be valid. At this point, we can talk about 4 different assumptions for a one sample t-test, and you can see the list of the assumptions. 2 of them are related with your research design, and the other 2 need to be controlled by statistical analysis. First, as you can see, independence of observations, which means scores should be independent from each other. Each data entry should be independent from each other. You couldn't take a mean calculation for 2 participants, for example. Independence of observation. The testing variable should be continuous, which means scale variable, interval, or ratio type of data. And we will conduct analysis based on price of primary vehicle. So it's a type of scale variable, as you can see in the numbers, numerical data. So it fits. And one of the most important thing to conduct, one of the most important assumptions is normality, as it is the assumption that we should meet for all parametric statistical analysis. The scores in the sample should provide normal distribution, which means normality. Skewness and Curtis values, Kolmogorov-Smirnov, Shapiro tests are the ways to test these normality, to check these normality assumptions. And the last thing is no outliers, no extreme values should have in your dataset. So first you should check this assumption tests. For the normality test and outlier tests, you can also watch first steps in SPSS data analysis video as well. So let's conduct one sample t-test analysis. Go to the compare means segment, and I open the pop-up window with one sample t-test, and I just drag price of primary vehicle or just click on the row. So I select my testing variable. In the options menu, you will see the confidence interval percentage, which is 95% as a default, 5% margin of error. That means 95% confidence interval. So that's okay. If you have any missing value in your in this data set, you can use exclude cases analysis by analysis or exclude cases listwise. If you select this one, it will the system will eliminate the case if you have any missing variable for the other variables, and it will just focus on the first one, whether there's a missing variable in the age and years column. So as a default, it was selected. It's selected, but if you select listwise, that means if you have any missing variable in any of your variable, it will eliminate these data entries before conducting one sample t-test. So they will stay as the default values. Bootstrapping is not important. Now you will see a testing value. Just imagine that when you look at the data view, the prices, car prices that you based on your data, there are different numbers about the price of vehicles. So imagine that we just know that the population mean price of primary vehicles is about $35,000. So I just write, sorry, so for the testing value, I should just write 35 as a predefined value. So this is the population mean for price of vehicles, price of primary vehicles, and I will compare my data with this value. I will check whether there's a difference between these two values. Now, when you click OK, you will see the output of the data, the descriptive ones. How many participants do you have in your data sets? About 3,000 participants. The mean, calculated mean value for the price of primary vehicle from this sample, standard deviation, and also standard error of the mean for the following data set are calculated in the descriptive parts. Now, when you look at the second table, one sample test, it shows you the results of statistical analysis, one sample t-test, and you will see that there's a t-value, calculated t-value, and degrees of freedom value, which is -1 of your number of participants. And since it's two-tailed, we don't have a directional hypothesis, the testing value, mean difference between the testing value and the calculated mean for your sample, and your confidence intervals. Now, when you look at the significance value, it is lower than 0.05. That means there is a significant difference between the price of primary vehicles of your data sets with the population parameters. So we found that there's a statistically significant difference. While reporting it, we can say that we can report it in a way that price of primary vehicles, for example, price of primary vehicles was statistically significantly lower than the population prices, and technical reporting with the T and DF values, and we just write p-value as 0.01 or 0.001. You can also write mean price of primary vehicles was lower with a mean and standard deviation was lower than the population normal prices, population mean prices of vehicles 35. Also, in reporting quantitative findings, I strongly advise to buy and look at Skylar's Hack amazing book, which is titled as reading statistics and research, and I just want to share an excerpt from this great book at the end of this video. Now, while reporting the findings, it's better to add effect size in t-test analysis to your reports. Effect size is a quantitative measure quantitative measure of the magnitude of the experimental effect or difference effect for the difference. The larger the effect size, the stronger the relationship between two variables, and the famous effect size that can be used for one sample t-test is quantity value. But how you can find quantity value? As you see, we couldn't see in SPSS analysis, but by just writing, for example, by just writing Google as effect size calculator for one sample t-test, most effect size can be calculated through web pages, and you just click on one of the pages and you will see different effect size calculators. For example, effect size calculator for one sample t-test, the testing value, your mean value, your dataset's mean value, and the standard deviation. When clicked on calculate, let's do the steps. Actually, you found that we know that it was 35. The mean value for our case is 29.86, and the standard deviation is 58, and click calculate. Sorry, problem. Let me change it with the value. Sorry, the effect size for one sample t-test is calculated as this one, and if the effect size is close to a actually it's calculated as the effect size is calculated as the difference between the mean of datasets and the default value, and later all divided by the standard deviation of the datasets. And if this calculated d value is close to 0.2, it represents a small effect. If it is close to 0.5, that means you have a medium effect size in your analysis, and any value close to 0.8 or much or large, it can be considered as a large effect size. The values might make sense if we say it in this way. For example, if two groups, for this case, for example, if two groups means don't differ by 0.2 standard deviations or more, the difference is like a trivial, unremarkable, even if it is significant. So our value is a little bit above the threshold value 0.2. So we can say that we have a small effect size value calculated in our analysis. So that's all we can say about one sample t-test, and in the next video we will continue with independent sample t-test analysis. Thank you very much.